Alright, so we're going through the Jeol EDS option on the screen, and what we're going to do is click the EDS button on the right hand side, or we can click on the top row which has analysis, and that's another way to get to the EDS function over here. Now one thing you want to do when you do switch over to EDS is go over to the chamber scope and freeze the image. And you'll notice we have a dead time reading that is in green right now. You're looking for a dead time, you want to make sure it's in the green and around 40%, so anywhere between 20 and 45% is where that's going to be green. We're going to click conditions. We have different T values. That's our time. So the lower the T value is going to give you more counts, and the higher the TV value will give you, or the T value will give you higher resolution on your scan. And we always want to check this while we're actually running a scan. So if you just saw me run that, I did click start because I don't really trust that dead time until it's actually doing a scan. In a sense, you can't change conditions after you start a scan, so you have to exit out of EDS mode, change your spot size, and if we want to increase the spot size or increase the dead time, we're going to increase the spot size. And when we do that, we're always going to have to change our focus because our conditions have changed. And please see the previous video for getting better resolution on the screen. So we're going back to EDS, and now we show a dead time of around 30 with about 50,000 counts per second. And that was on T3, so we switch it to T2, and we're actually going to run it. And we see our dead time drops, and our counts go up slightly on that. So we're going to stop that scan, go back to the conditions, and set it back to T3. So again, we'll start the scan to get an accurate reading. And again, we're just a little shy of 30% on the dead time. Now we want to go to our data. So that first one was just that practice run, because it will save every time you do press start. So we're on the second one right now. And it is inquiring, and you'll notice above the periodic table at the bottom, we do have time remaining on the scan. Just for demo purposes, we're just running this at 60 seconds. Alright, so we have finished our scan, and again, that first one was just a practice, so I'm going to remove that. So now we're on number 2, and we can enlarge the graph. And typically I will put this in a log counts mode instead of the linear mode, so that way you can see the small peaks a little bit better. And we have some labeled peaks on there, carbon, aluminum, and tin. And we have a couple that aren't labeled, so there's two ways you can see those. You can either double click on a peak that isn't labeled and kind of look in the list that'll give you to see what it could be. Now this one, if I had to guess, it's probably an oxygen peak that's on there. Now the second way to look at the elements is actually click onto one of the buttons, and you'll see a line appear where the peaks should be. Now some of them are going to have singular lines, some of them have multiple lines, like the tin. You see those blue lines that are, let me enlarge that. You see the blue lines on there? And we have a small one next to the tin peaks, and then all the tin peaks that are labeled. So any element you select, it will give you the peaks that are supposed to be there. And you'll see different heights on these peaks when there's multiple peaks, and that just means they need to be in those proportions for the heights. So I added oxygen, and I'm going to make sure I hit the quantify button and then the print button for my report. Now you hit the quantify button to save any elemental changes that you made. And now we have our report with our carbon, aluminum, and tin that the computer selected, and then the one we added for oxygen on there that I selected myself. So it will give you your mass and atomic percentages. It'll also give you the data for the scan also. Your accelerating voltage, dead time, and your counts per second rate also. So we're going to close that, and we're actually going to take off the oxygen, hit the quantify, and then recreate the report with the computer selected elements that we have. So this one just has the carbon, aluminum, and the tin. So now, instead of just doing an average scan around the whole picture, you can do individual points as well. So I select on my point option on the left, and then I will click on the points I want to get the data from on the screen itself. So I have 1 point on one of the actual tin spheres, and then 1 point on the carbon tape that was underneath the sphere that had been removed. And if you need to delete a point, just right click and you can delete the point. And again, our scan time should be the same. Our scanning conditions will be the same as last time. And now we'll notice that the dead time is a little bit higher on the first point. Now that's going to be because on the first scan, it was taking an average of the whole image. So you're getting some carbon and some tin. And carbon being a lighter element, it's going to give you less counts off that. So the dead time is going to be reduced. So now we're looking at just tin itself. It is going to give a higher dead time. And when we move over to the second point for the carbon, it is going to give you a lower dead time than the average, because now we're just looking at the lighter element. There might be a little bit of residue of tin on that one, but overall it will give us a lower dead time. So since we had the condition set for 60 seconds, it's doing 60 seconds at each point. And now we're finishing up the first point. It's going to automatically switch over to the second point. And now we're just looking at the carbon peak, which might have a little bit of tin residue on there. But we can see the tin peaks are much lower than they were before. Our dead time is also reduced to about 15%, where it was around 40 before. Counts are also a little bit lower also. So this is just an effect of the material you're going to be scanning. So the lower, the lighter elements that we're scanning, it's going to give less of a response when we're taking data. All right, so our scans are finished. And again, there could be a slight oxygen peak on there, so it's going to be up to your judgment whether to add that or not. I'm going to go back and take it off and just leave it as is, as the software identified it. So now if we look, we're only getting an image with spot 2 on it. And the point of doing multiple spots, we want to see that image with both the spots and then get the data with both the spots. So what we're going to do is we're going to select both points, so hold down your shift, and then create the report when both are selected. As we can see, the 2 graphs are on there. 2 spots are going to be on the image, and then you'll have your 2 analysis points also for spot 1 and spot 2. So now looking at this data on the right, we can see our conditions. The dead time is about 15%, so this is actually the conditions for that second spot. And if we want to get the conditions for the first spot, we're going to select the second spot first and then select the first spot. And then if you see the 001 at the very top left, and then now we have our dead time at 47%, which corresponds with that spot 001, which we're getting off the tin. All right, so now we're going to take a look at our elemental distribution through our mapping function. So we're going to check the conditions for the mapping, and typically these are set correct. I will select qualitative analysis to be auto. That's pretty much the only change I usually make on this. We're going to click our map button instead of the spectrum button, and we're going to click start. And as you'll see, it's going to self-identify the first three elements again, and now it's going to break them up into different colors. It'll have separate colors for those, and now you'll be able to actually see the distribution according to the image that you took. And be aware, there's other times that different elements will pop up, and then they might disappear toward the end of the scan. It's all going to be about what percentages it sees and how it figures out these algorithms to identify these elements. But just wait till it's finished, and then if you need to change elements, we could do it pretty much the same way that we did with the spectrum. All right, so we have our map completed. And again, it identified the carbon, aluminum, and tin for our pictures. And now you can see in the color maps the distribution of those. So we're going to take a look at the report. So to get the report, we're going to hit the quantify button, and now it's going to give us our elemental analysis on the report. And you see at the bottom, see our percentages for carbon, aluminum, and tin. And just looking at the aluminum, it's a very small percentage that it shows. So we're going to actually take a look at that without the aluminum for now. So if you look at our scale bars on the left side on the actual images itself, we're going to kind of look at them and see what the max and mins are. So they'll all start with zeros, but if you get an element where it only goes to 20, 30, 40 counts for the contrast for the colors, then it might not actually be in there. If we look at our carbon and our tin peaks, it's going to have a lot higher, a lot larger scale on that color bar on the left side of each color image. So that's one way to kind of identify if it is actually a true image. So when we are selecting our points, we need to make sure we hit our quantify button after we remove a point or if we add a point. So now we have just our carbon and tin in our elemental analysis list, and we took out the aluminum. So the label and the quantification for the aluminum is removed. Now, since it did auto-find it, I'm going to go ahead and put it back in and make sure you hit your quantify, then print your report. All right, so just as an example, there shouldn't be any iron in this, but if you need to add one, you're going to click on it till it's selected purple, and then press your play button. And that's going to re-image all the maps. And hit your quantify button, and then we're going to take a look on what the analysis is. So it's showing 0.02% for iron on there, which is very low. And that's something you're going to have to definitely question if you ever get results like that. But if you notice the stars right next to the elements, those ones with stars indicate the ones that you have added. Now I did notice on that one, tin wasn't shown on the list. So I'm going to redo the report and look, and I notice tin isn't there again. So this is something you're going to have to look out for when you're doing these reports of multiple elements. The way it lays it out, they are sometimes hidden. So I'm going to move that graph up, and I'm going to move my data bar up and expand it, and now I see my tin and my totals. So just be aware that if you have multiple elements in this with your images, if it's going to cut off close to the bottom of the page, you're going to have to actually move that table of data so you can expand it to see the total. So I'm going to take the iron back off. And again, you're going to hit play. That'll rebuild the elemental maps. We'll create the report. And now I'm left with my carbon, aluminum, and tin that is on there. Again, that little star is going to be the one that we added manually ourselves. But actually, if you remember, it did pick up on aluminum the first time. We took it out and then re-added it again. And that's why it has a star now. Now, one thing you will want to do with any of this EDS data is you will want to save it into your folder. So that's where if you did want to add that aluminum back in and you didn't the first time, you don't have to rerun your sample. So we're going to save this, and then we're going to open it back up, and I'll show you how to access that. So we'll save that, and now we're going to click on album, and that's where we're going to be able to retrieve some past data that we had. So we're going to click to change folder to find our data that we just saved, or any previous data that you had saved. And then we'll click on that image that we made, and then reanalysis is the button we're going to select. So now all of our EDS data that we got the first time is going to come back up. And if we so choose to change our element map at some point, let's assume we want to actually get rid of the aluminum, we can. Again, you press play, press quantify. After it's played, print up your report. And then now we have our data without the aluminum, just the carbon and the tin. So again, don't forget to save your data. If you think there's a chance, or even if you don't think there's a chance that you might have to reanalyze it, it's much easier to just play with the data instead of reanalyzing your sample again. So upon finishing your EDS, we're going to click the monitor button to return to the normal observation mode, and we're going to follow the normal closeout procedures where we're going to reduce our magnification to 0. We're going to tilt back to 0 if we were tilted, and return the sample stage to a position of 0, 0. And again, we're going to just close the software, or turn off the beam, close the software for the chamber scope and the InTouch software for the SEM.